So, a little bit about me. My name is Josh Long. Thanks very much for coming. I appreciate that on such a day as today, you have many, many fine options, many places you could be. So thanks for being here with me. I'm on the internet, so if you're on the internet, I'd love to carry this discussion forward. How many of you are on Twitter? Twitter. It's 2016. 2016, Twitter. Who's on Twitter? Awkward. What about email? Email. How many of you have email? Does anybody have email? Anybody? No. Okay. That's awkward. So either way, I'm on both of those social networks. Don't hesitate to reach out to me. I'd love to chat, okay? Add me on the email or the Twitters. I'm happy to talk. I'm an open source engineer, open source contributor. I'm very proud of my contributions. I am #1, top ranked, most contributions of bugs every year for 7 years. More bugs per commit than any other developer. #1 bug committer, very high ratio. I didn't fix them, I added them. That was the problem. Never mind. Anyway. I'm also an author and a training video leader, instructor. I've written now almost 5 books. I'm working on my 5th, the latest and greatest of which is called Cloud Native Java. So that's going to be there eventually. I've done several video training series. These are on the Safari online marketplace. They're usually ranked in the top 10 or top 20 of all videos, along with other videos like .NET and Java. So there's that. And I am a Spring developer advocate and a Java champion. These are two... Okay. These are 2 roles in which I have the pleasure, the privilege, and the opportunity to be before audiences like your very selves to talk about something I love, which is building applications at scale. I work at a company called Pivotal. How many of you have heard of Pivotal? Pivotal is a small company with a big heart. We're the home of Spring. We make Spring. How many of you have heard of Spring? Spring. Okay, so we are the people that make Spring. How many of you have heard of Tomcat? Tomcat, Apache Tomcat. Okay, so we're the lead contributors to that as well. How many of you have heard of RabbitMQ? Okay, good stuff. And what about Cloud Foundry? Cloud Foundry. So Cloud Foundry is an open source platform that's optimized for the continuous and safe delivery of applications into production. It's a platform that manages the life cycle of an application from deployment to management and to scaling out. It's open source, but it's being used by lots of other companies. They have distributions. We have a distribution. There are lots of small companies out there that have taken the core of the code, which we open sourced, and used it to build their own distribution, very much like the Linux kernel model, right? In fact, Cloud Foundry is managed by the Linux Foundation, right? How many of you have heard of some of these companies? These are other companies that have distributions. How many of you have heard of IBM? IBM. What about HP? Anybody? Well, you watch this space. One day, they're going to be important. Not now, certainly. But in the future, in the very, very distant future, they may be important. IBM. Watch this space. We are Pivotal. We, of course, have a distribution as well, right? We do a pretty good job. Imagine if Linus Torvalds built his own Linux distribution. Wouldn't it be the most amazing distribution of Linux ever? Yeah, well, we built our own of Cloud Foundry, right? So it is the best. So we have lots of great open source stuff at Pivotal, but this is not the reason that we wake up excited to go to work in the mornings. We're not here to build open source. We love open source. It happens to be a great way to achieve what we're trying to achieve. But the reason we are excited in the mornings is because we see that organizations and developers and users all around the world are struggling with this notion of speed. They need to go faster. And this is not a controversial idea. I don't think we have to look too far for examples where speed is a differentiator, right? What is the largest taxi company in the world? Anybody? Taxi. Thank Uber, exactly. What is the largest video rental service in the world? What? Netflix, thank you. What is the largest, in terms of year-over-year growth, car company in the world? Tesla, right? And what is the largest hotel company in the world? Airbnb. These companies, when they started, didn't have more money, didn't have more intelligent people, they didn't have anything. They just had the ability to go fast. This helped them go much faster and make more mistakes and then fix those mistakes faster than the competition. It creates a new reality where if we are building software today, and almost everybody is after all, then we are obliged to find ways to go faster, to move from concept to production. And what we've seen is that organizations struggle with this. They have existing applications, they want to change these applications and move them into the production environment, but they realize that the act of developing software is itself fraught with lots of different activities that are very painful. And then production itself becomes kind of difficult to get to because there are all these production concerns that you have to address. Non-functional requirements that, if you don't have them, will gate your ability to move software into production. These non-functional requirements, I'm sure most of them know about them. How many of you have ever seen the terrible wiki page, 500 easy steps to production, right? Inside the internal organizational wiki? So anyway, most organizations have a terrible wiki page that tells them all the things that they need to care for before they can move software into production. This wiki page is called the 500 Easy Steps to Production. And that wiki page is the enemy of velocity. It's all the crap that we have to take care of to be able to move software into production and go fast. In order to go fast, we need to find ways to make this stuff consistent. So what we're going to look at today is something called Spring Boot, which we can use to quickly stand up services and then handle non-functional requirements like, for example, operational and production concerns. Okay. Wait. Can you hear that? That's really awful. Okay. So we're going to begin our journey today at start.spring.io. Start.spring.io. This is my second favorite place on the internet after production. So remember, production is my favorite. I love production. You should love production too. Production is great. Bring your family, bring your kids. It's awesome. It's the happiest place on earth. Production is better than Disneyland, and you should go as much and frequently as you can. So if you can't already be in production, then you are going to have to start your journey to production here at start.spring.io. If you wake in the early mornings and you lack inspiration, start.spring.io. If you have heartburn or indigestion and you seek relief, start.spring.io. And if your children can't sleep, if they're restless, start.spring.io. This is my second favorite place on the internet. Like I said, after production, bookmark it, keep it close to your heart, keep it under your pillow. And then what we're going to do here is we're going to build a very simple application, a very, very simple application using a lot of different technologies. And the goal here is not to remember how to build any particular part of the application. It's to understand that it's possible to do it and understand that it's very quick to do so. So we're going to build a simple service. I'm going to call it the reservation-service. I don't care all that much about the domain model that we use. I just want to have something with which to play, an example on which to iterate. So we're going to build a simple application. We're going to use H2, the in-memory embedded SQL database, right? Every single time the application starts up and then dies, it's going to throw away the content of its data in memory. H2, we're going to use JPA, the Java Persistence API, because I make bad life decisions. So JPA. I'm going to bring in Actuator for operational concerns. I'm going to bring in REST repository support. I'll bring in Spring MVC web support. I'm going to bring in the remote shell support. I'm going to bring in a client-side technology called Vaadin for building a user interface. And what else do I want to bring in? I suppose I could, of course, elect to show the full version. And here I can see that if I don't remember what I want to select, I can always just manually browse through the various options here. You'll see that there's all manner of different technologies that are supported here. Some of which I've already selected and used, right? So if you can't think of what you want, there's probably an option here. I would encourage you to consult this list when you can. Now, remember those stupid ads from Apple? Those stupid, stupid ads? There's an app for that. Screw that, right? There's a checkbox for that. This is much better than an app. So what we're going to do is we're going to go ahead and build a simple application. And I have choices here. I have choices here that are very, very hard. I think a lot of people really struggle with these choices. These are non-choices. These are choices that you could decide to make if you wanted to, but that's a terrible idea. You shouldn't make these choices. These are choices in the same way that walking in traffic naked is a choice. You could, but don't. Don't. Okay? So, for example, you could change the language of the language you want to use. That's fine, actually, here. Any language that supports annotations and objects on the JVM will work just fine. So Java, Scala, Groovy, Kotlin, whatever. Choose, but here, you could, this is a non-choice, right? You could use one of these other versions of the JVM, but don't. Just don't, right? These are end-of-life. They're not supported. To use them today would be irresponsible. You would be actively jeopardizing your organization and your friends. You're going to make your cat sad. Do you have a cat? Not yet? That cat is going to be sad. Okay? And then here we have the choice about the packaging. What kind of packaging? And people get very confused here. They struggle with this question. They don't know what kind of packaging to use for their application. So I'm going to explain here and now when and where to use which kind of packaging. If by some crazy, crazy freak accident of physics, you find yourself stuck in the very, 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 very distant past, very, very far in the past, long beyond modern help, then choose .war. But if you're here with me today, in 2016, then choose .jar. This is a big part of my overarching personal philosophy of make jar, not war. And again, you have options. You have choices. You should do what works for you. Okay? Now, I'm going to go ahead and hit generate. Or not. Hello, Internet. Who's ever torrenting, would you stop? Son of a gun. Come on. Come on. There we go. Go through this again, quicker. Web, JPA, actuator, generate, fine. So now I've got a zip file and a project that I can open up in my IDE. Again, it doesn't matter which IDE you use, we don't care. There are many great options. How many of you are using IntelliJ? IntelliJ, good stuff, hot sauce, well done. What about Eclipse? How many of you are using Eclipse? Good stuff as well, right on. What about NetBeans? NetBeans, good stuff as well, nice choice. Either one, any of these are good choices. So it doesn't really matter. What about what about Emacs? Emacs, are you here? Are you here, sir? Are you? Yeah, there he is. This guy is in every talk I give. I go to many countries all year, dozens and dozens of cities. I don't know how he's in every one of them, but he follows me. It's very strange. It's the same Emacs guy in every conference. So anyway, we have here a regular Maven build. This is a very, very simple Maven build. It's a stock standard Maven build. And you can see that we have here a Spring Boot starter parent. This parent, in turn, contains other parents. And here you can see that we've taken the liberty of level setting common dependencies. We've managed the versions for you so that you don't have to worry about them. So you can see here all the different versions of common third-party ecosystem libraries already managed for you via these properties. You can override these properties to override the version of the dependency that you are using. We have people on the Spring team who are bald, no hair, none, gone, all of it dead, just gone, because they have solved this problem for you. They have managed these dependencies for you. And the benefit, of course, is that when we go to our actual code, we are given these opinionated starter dependencies. These dependencies are opinionated in that they don't provide any actual code. All they do is they bring in other dependencies that you can use to build applications. So, for example, Spring Boot starter data JPA brings in everything you will need to build a modern JPA-based application in 2016. It brings in Hibernate 5.x, it brings in JPA 2.x, ORM support, transaction support, Spring Data JPA, etc., etc., etc. So you don't have to waste time level setting all these different dependencies and trying to make them work. Once we've got that, we have a public static void main. How many of you remember public static void main? This is what we did before we were all taught that you have to deploy everything into a web container. Do you remember that in university? Nobody did that in university even? Even your first Hello World program went into an EGB container? That's disgusting. So we have public static void main, and here, this is an annotation. This annotation is a Spring Boot annotation, but it's actually a shortcut for 3 other annotations, which are these right here, right? So this annotation is the same as these. This one tells Spring that this class can define bean provider methods, e.g. @bean foo, like this, return, whatever, right? That tells Spring that this is a method that returns an object that it's supposed to manage. That's this one. This one says to look for every bean in the current package or below, and then register it and manage it via Spring. And this one is the one that turns on Spring Boot. Now, I like this annotation. I'm not saying it's bad. I'm just saying that I had a disagreement with the Spring team, okay? I'm just going to go ahead and say it. I'll just say it right now. I just want to share. I feel like we're friends. We can talk openly, okay? I disagreed with the Spring team on this one. I thought we could have done a better job in the naming of this annotation. I thought it should be something like, I want to go home early. But again, nobody listens to me on the Spring team, so whatever. That's fine. Okay? So anyway, we named it Spring Boot application, and what we can do now is we can build a very simple entity, and I'm going to build an entity called reservation. And we don't care about what's in the entity too much. I just want to have an object that we can work with. So I'm going to say private long ID. I'm going to make it an auto-incrementing surrogate value at generated value at ID. I'll create a field here called reservation name. Now, reservation name is a field that'll be mapped to a database column like this, reservation underscore name. And I'll say at entity. So this is the purest expression, the essence of the domain model. It's absolutely beautiful, don't you think? Look at that. It's so clean. But this is Java, so that isn't even close to enough. So we're going to add some getters. We'll add a constructor. We'll add another constructor here for JPA, right? There's this. We need a toString, so we'll add that. And there we go, all that crap. Now we have a regular JPA entity that we can use. Now, what we want is to store and read and write instances of this record to the database. And to handle that, we're going to use something called a repository. A repository is an object that, if you've ever read Dr. Eric Evans' amazing book, Domain-Driven Design, you know that it sits between your business logic and the underlying persistence tier. It handles reading, writing, updating, and so on. This is boring business logic. You're not going to get promoted for writing this stuff. Your business will not be in first place or second place by spending time on this. This isn't going to help anybody, but you have to do it in order to write a useful application today. So the goal today is to remember that we want to write as little as possible. Remember, nobody is going to ever come to you late on a Friday night and put their hands on your shoulders and say, good job, well done. You wrote the best select all from foo, where ID equals question mark. Nobody cares. So we don't want to write more than a minute of code on this. We're going to use a declarative Spring Data repository. This is called, we're going to say reservation repository extends JPA repository, managing entities of type reservation whose primary key is of type long. Now, JPA repository is provided by Spring Data. There are other repositories for MongoDB, for Cassandra, for Neo4j, for Couchbase, for Geode, for whatever, right? All sorts of other repository implementations. This is not, however, one implementation for all of them. This is different best-of-breed technology implementations for each of them. So here we have a JPA repository which extends paging and sorting repository. Paging and sorting repository works for JPA because JPA is based on SQL. So it does a good job with ad hoc paging and sorting. But for example, the Cassandra repository will not be a very good fit for that, right? It doesn't do paging and sorting very easily. So you won't see that. You can also define custom finder methods. You could say, I want to provide a finder method for entities of type reservation, and I want to search for them by their reservation name, string, rn, etc. So here we go. This is a very, very simple interface, and we have a finder method that's created by convention. It's going to search all reservations by the reservation name, right? Like that. So that's by convention. Of course, we could override it. We could provide our own override query method like this. That's fine as well. Doesn't really matter, right? But in this case, we're fine. We don't need to override it because it does the job for us. Now, what I want to do is I want to create an object that writes records to the database, just some sample data, so that we have something with which to play, okay? So we're going to say class dummy CLR implements command line runner. And we're going to override the command line runner interface. And the command line runner interface is a Spring Boot interface that just provides a callback. It's a notification. It gives you the chance to do any kind of startup or initialization logic that depends on the public static void main string arguments. String args, right? This is an object though, so of course you can take advantage of the fact that it's being managed by Spring, and you can ask Spring to manage certain things like collaborating objects, right? The correct way to do this is to use a constructor and tell Spring that you want that bean as part of the constructor. You should do this all the time. For every dependency that is required, make a constructor argument. The wrong way to do it is to do this, @AutoWired. Every time you do this, a unit test dies. Every time. So prefer constructor injection. We're going to say @AutoWired. Good, so now we've told Spring to give us this bean by type and to inject it. Here we can say stream.of, and I'm going to create some simple records. My name is Josh. I've got my friend Andre here. Okay. What's your name? How do you spell? Like that? Thank you. Nice to meet you. What's your name?
San. A-E-E. Your E.
Oh, move your finger. Thank you. E-E.
R-S.
There we go. Like that? Oh, like that?
Yes.
Okay. That's 6. That's an even number. I will sleep well tonight, so that's fine. And then we're going to tell Java 8 to visit every record in that stream, to visit every record and pass the value in that stream to a callback method here. This is a consumer from Java 8. Now, I don't know how many of you have had the chance to play with and use Java 8. Java 8. And now we have the essence there, and I'm going to actually remove the body because I've only got one expression. So I'm going to say reservation repository.save equals new reservation name. Good. And then I'll say reservation repository.find all, and then for every record that comes back, I'm going to say print line. So I'm going to tell Java to call the print line method for every record that's there. Now, we're going to go ahead and run this, and we should see, if everything goes to plan, we should see, let's see. Oh, there it is. Look at that. It worked. Huh? Every record in the database, it has a primary auto-incrementing key. There's all the names. That worked. Of course that worked. This is a demonstration. What were you expecting? It was always going to work. Instead, what I really wanted to focus on was this. This is the Spring Boot ASCII artwork. This ASCII artwork was developed by the Spring team over many, many years. It took a long time to get this right, but we did a good job. We have people on the Spring team who are doctors, PhDs, people who in their previous lives worked in nuclear physics, star stuff, the very celestial bodies in the heavens above us was their daily bread and butter. So it makes me very happy to imagine that someday, somewhere, somehow, they got a GitHub issue that said, damn it, we need good ASCII artwork. And look at this. It's absolutely amazing. I'm a big fan of IntelliJ. I like the IntelliJ product. I think they've done a good job. But I think that in their 14.0 release, they added a really big bug, a big problem. What the hell? Why is this here? This is a dumb feature, and it needs to be taken away. Who would ever do that, right? So some people ask me sometimes, can I change the banner artwork? Can I change it? Can I overwrite it? And that makes me very upset because it's a stupid question. Why would you ever want to change it? You could not do a better job than this. We have doctors. But I was just in Canada a few weeks ago, and I don't know if you've ever been to Canada, but it snows all year. Even in the summer when the sky is blue and it's hot, snow. We don't know how. They have snow in between rain. They'll have the raindrops and the snowdrops at the same time. It's just raining and then snow. It'll be sunny and then snow. All year, just snow. Doesn't matter. So they spend a lot of time inside. All year, in fact. So they're very talented. They have a lot of great artists who draw pictures of days when it's not snowing. So because there are very talented people in Canada, I feel like I could show some of you how to change the banner artwork if you're from Canada and you have very good design skills. So what I'm going to do is I'm going to go to my terminal here, and I'll go to the desktop, and I'm going to take my little banner.txt and copy it to my source main resources directory. And then having done all that hard work, you can see it's here now, right? Source main resources, banner.txt. I'm going to restart it. So now we have very good banner artwork. Now anyway, we have an application that's reading and writing to the database. We're able to do queries. We're able to do all sorts of cool stuff. But we are confronted with an existential philosophical question. If we write data to the database, but no one can read the data from a REST API, did we actually write it at all? And the answer is no, we didn't. So we need to build a REST API. There's a couple of ways to do this. We can return to our build and bring back Spring Boot Starter Web here. That's this, right? That's one way to go. We can say @REST controller, hello, class reservation, REST controller, right? And I could create a private final reservation repository and inject that, create a constructor, @AutoWired, and say @request mappings, method equals get, value equals reservations of reservation, And I could return it like this, right? And that would work, right? That's a very simple REST API, but it would actually work. But if you look at what I've done, I've written a lot of code, a lot of extra code with very little gain. What I'm trying to do is map the business state transitions that my repository already knows about to the appropriate HTTP verb. So localhost 8080/reservations. Here we are. And you can see that worked. Not very interesting, but it worked. But again, that's a lot of extra boilerplate. So we're going to remove that nonsense code and just let the repository, which already knows how to do the reading, the writing, the updating, and the deleting, do the heavy work for us. I'm going to bring in Spring Boot starter data rest here. And I'll go back to my code and I'll annotate the repository which I've created and make it a Spring REST API. I'll say repository REST resource. I'll say at REST resource. Path equals by name. Okay. And I'll annotate this as a param, rn. Here we go. Stop and rerun. Oh, can you hear that? So, now if I revisit this, I have the same basic information, but I have hypermedia, links. These links are metadata about the resource. They give the client the ability to understand what they can do with the resource without having to read the documentation. This is an implementation of a design pattern called HTOS, or hypermedia as the engine of application state. It's the idea that you are going to support self-describing APIs. When you move to a distributed systems world, providing as much information in the API itself is valuable. It's very, very valuable. So we can add and remove custom links. We can do all sorts of things. This is a very, very useful design pattern in a distributed systems world. So now we've got a REST API. We've even got support for searching, right? I can go to / and I can see that if I go to reservations, it supports paging and sorting. I can say page equals 1 and size equals 2. And I get the results, right? I made the paged URL. And I also have, of course, build a regular Spring MVC controller. How many of you have ever used Spring MVC? Spring MVC is kind of a thing, right? So we can say add controller class reservation MVC controller. And what I'm going to do is I'm going to build a simple demo endpoint. And again, this endpoint, it's a demo, my friends. So because it's a demo, I'm going to do something silly. I'm going to give it a name that I would never, ever, ever actually use in production, ever. Something that would be insane and that you would immediately get fired if you did this. Something like reservations.php. Now, that's a simple page. And what I'm going to do is I'm going to tell Spring MVC to provide a model object. A model object is a glorified map and has keys and values. These keys and values are available for rendering in the template. So I'm going to say model.addAttribute, reservations. And here I'm going to rely on a repository like this, create a constructor, and I'll say add AutoWired. Okay, and I'm going to say this dot reservation repository find all, and I'm going to say return this string. This string is going to be plugged into something called a view resolver, which is going to apply a little heuristic, an algorithm to determine a template to render. So by default, it's going to look in source main resources templates plus x, which is the string plus .html. And the reason it's going to do that is because I'm going to provide a template rendering engine. This one I'm going to use is called TimeLeaf. So I'll say bring in Spring Boot Starter TimeLeaf. Now TimeLeaf is just one of many different kind of rendering technologies like Velocity, FreeMarker, Mustache, JSON views, etc. You can use anything you want. You can even use .jsp, but don't use JSP. That's a terrible idea. There are better things on the sidewalk for rendering HTML on the server than JSP, so avoid it at all costs. We've brought in TimeLeaf. TimeLeaf is an HTML5 friendly templating technology. Have you ever given a JSP page to the designers and then the next day you come to your desk and there's a bag of poop on fire? You ever have that? No? That's JSP. So don't make the designers angry. Give them something they can use. So we're going to add a little template here. Reservations.html. And I'm going to cheat here for want of time. I'll say beautiful microservices. Oops, reservations. I'm going to copy this HTML. Actually, there we go. Paste that in there. And now, having done all that, I'll go ahead and restart. This is I'm using a dynamic page here. Of course, I could also create a static page here, like hi.html. Just say h1, hi, okay? And I can restart this as well, but let's see if this worked first. So localhost 8080 /reservations.php. There's my simple Spring MVC endpoint, right? I can also restart, and I've just added the static, HTML. If I have React or Angular, JavaScript, CSS, I put that in the static directory. It automatically gets served. So now I can go to hi.html as well. There's that. Okay, localhost 8080 UI. So there's my very simple Vaadin grid, and you can see it's got a sortable, clickable, draggable, whatever user interface. You can see that there's no actual HTML. All of this is client-side JavaScript. The components are transpiled into JavaScript. It's built on something called GWT, Google Web Toolkit. So the results are very fast, and you get results very immediately. Now, this is an application, but are we done? Probably not, right? We have operational concerns. And so for the last 8 minutes, we're going to talk about that. I want to make my application visible, observable. In a production system, there are things I need to be able to understand about the application that are only clear, they're only visible if we make them visible for operational concerns, monitoring, metrics, and so on. So what we're going to do is we're going to go back to the build, and we're going to bring in Spring Boot Starter Remote Shell and Spring Boot Starter Actuator. Okay? And we have production concerns for deployment as well. So what I'm going to do is I'm going to go back to my build here and make this executable. Okay? So let's restart the application. Drink some water. Let's talk about the actuator and what that does first. So the actuator is a set of endpoints that expose information about the application. So there's my Vaadin user interface, there's my REST API, my PHP page, etc. And now if I go to /metrics, metrics gives me keys and values, information about each host and node on the application. So here I can see the memory, the heap, the non-heap, the processors, the code cache, all this. I can even see a set of counters that show me information about the application. I made 2 requests with status code 200 to /UI, right? I can see here how much threads I got. I can see here I made 1 request to reservations, status code 200. The metrics endpoint right now supports 2 kinds of metrics, counters and gauges. A counter is a value that goes up 1 by 1 or down 1 by 1. 1 more new HTTP request, 1 less job on the task queue. A gauge is an absolute value. How much RAM do I have right now? I have 2 gigs of RAM. How many users are in the chat room right now? There's 2,000 users in the chat room. Whatever, right? These are different kinds of metrics. But these metrics don't tell the whole story. We cannot use these metrics as they are right now to understand how the application is doing because we don't know what they were before. We don't know what these values were a minute ago or an hour ago. We need to be able to understand what these values represent over time. In order to do that, we can use the Dropwizard metrics library. How many of you have ever heard of the Dropwizard metrics library? So the Dropwizard metrics library was built by one of my heroes and one of my spirit animals, a gentleman named Coda Hale. This is Coda Hale. And this is also Coda Hale. He's awesome. So he built this metrics library, and the metrics library gives you the ability to collect histograms. A histogram is a statistical structure. It captures things like the mean, the median, the max, the average, the 95th percentile, the 99th percentile, etc., etc., etc. So this is one endpoint that's very useful, is the metrics. We also have ENV, which gives you an enumeration of the environment in which the application is running. This supports 12-factor style configuration. So the idea that you want to keep configuration from one environment to another external to the code. This is very, very useful. We also have mappings. And mappings gives you an enumeration of the endpoints that are available and whatever information we have about their exposure from Spring. So we see that there's a reservations.php, which supports HTTP GET, and it lives on this controller, etc. We have health. Health gives me an enumeration of the subsystems in the Spring Boot application, as well as their various statuses. If one of these says down, then the global aggregate status will say down as well. This also returns the correct status codes. So if you have a load balancer, you can use this to evict nodes based on status. Now, we may want to change some of this, right? So one thing that's very easy is we can customize these defaults. Let's say that we want everything to be at /admin, okay? And then what if I want to contribute my own health indicator? I can do this very easily a couple of ways. I can use application.properties and contribute things like management.contextPath equals admin. And I can go to my code and I can contribute a bean of a certain type. Component, class, custom, health, indicator, implements, health, indicator. And here, I'm just going to return a very simple health.status, I heart Turkish coffee.build. And of course, I could put other statuses like out of service or down or whatever, but what I wanted to do is just return my own custom health indicator and contribute that. So we've used two different ways. We used well-known properties, of which there are many, convenience values, right? And we used objects to override the default behavior. So here now, admin/health and my custom status, right? This is one of the things that's really nice about Spring Boot is it's very, very configurable, and I'll explain how that works in a second. But before we do that, one thing you also have to understand is that these management endpoints are exposed via REST, but they're also exposed via, for example, JMX. So if I go here, mbeans, endpoint, health endpoint, operations, get data, right? I love Turkish coffee. And they're also, in this case, because I have the Spring Boot starter remote shell, exposed via SSH. SSH-p 2000, user at 127.0.0.1. And we take this password here. Okay. Paste it in. Good, clean, quality ASCII artwork. Now you can ask for help. You say, give me some help. And it gives us options, and we can say system, prop ls, that's fine. I can say metrics, that gives me the metrics, updated live, I'm not touching the keyboard. I can also do endpoint invoke health indicator, okay? Or endpoint list, endpoint invoke health endpoint, sorry. And you can see there, I love Turkish coffee. One thing that I love in particular is the dashboard experience. So here, you have the Java top, all the threads in the running application, as well as the heap, the non-heap, the code cache, etc. So here we have all the different endpoints and their information, as well as how they're working. You get all this very, very quickly because Spring Boot is meant for production. It's meant to be visible. Now, I've shown you how to look at some of the information that the system is exposing. The last and final concern before we understand the auto configuration is how to manage and run this application. This is just, at the end of the day, a so-called fat jar, right? So if I go to downloads reservation service, you can see Maven -d, skip tests. Come on, gotta go faster. Come on. Clean, install. CD target. And this is a so-called fat jar, right? Do manage SS jar. 60 megs. That includes the SSH shell. It includes all of Hibernate. It includes my embedded web server. It includes JMX support. It includes Tomcat. It includes everything I need. I can add this jar to an attachment as an email. Send it to my grandmother. And because grandmother has the Java virtual machine for applets on her machine, she can run this. If you spend more than a minute running this, you failed. You can deploy this to any cloud environment like a Cloud Foundry very easily. And because I configure this to be executable, here, we get to do something very, very cool. Obviously, I can already do this. This is easy, right? Java minus jar. Anybody could do that, right? That's what we did before. But if I did that, I would have to write a script to manage the start, the stop, the logs, the PID, etc. So Spring Boot's management plugin does that. So quick question. Which direction does the JVM read a jar? Does it read it from the bottom up or from the top down? Operating systems read from the top down, but the JVM reads from the bottom up. So you have a bit of an opportunity for awesomeness. So you can do that. Executable jars. So that application's running, but I didn't have to run the JVM, and the reason is because of this. Script, 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 bytecode. The jar loads itself. It's a script that loads itself, and look at that. It supports start, stop, restart, etc. These are initd. If you put this jar in your initd directory, the operating system will start it up, it'll kill it, it'll status it, it'll make sure there's only one running, etc. You're already ready to go. So finally, all of this is working thanks to the beauty of auto configuration. The way auto configuration works is it looks for spring.factories text file in your class path, looks for meta-inf spring.factories, and it finds a long list of Java configuration class names like this one. Here, you'll see in the Java configuration that these are just regular Java configuration classes. They have bean definitions like we saw earlier, but they provide conditions. They say, I only want to evaluate this bean if this type is on the class path. So if the rabbit template is on the class path, then this class will be evaluated. It provides these default beans. We saw that earlier. I added Spring Boot Starter Web, and suddenly I had a web server. I added Spring Boot Starter Actuator, suddenly I have management endpoints, right? Adding libraries to the class path contributes to default functionality. But I can also override things. Here, for example, it says, if anybody creates a bean of type AMQP-admin, use that instead of creating our own. So it says only do it if the bean is there already. So, I want to thank you for your time. I'm sorry we ran a little late. I appreciate that we have other places to be. In summary, getting to production doesn't have to be hard. I did a whole bunch of everything today, just to show you how easy it was. I'll be happy to take questions. What do you think? Could you see some use for Spring Boot? Okay, good. Thank you so much for your time. I appreciate it. Cheers.